Hello and welcome to The Sleepy Scientist. This is your time to slow down, to let the world soften at the edges, and to drift somewhere quieter for a while. Tonight, we'll be gliding far from the bright familiar planets and into the dark outer reaches of the solar system, where forgotten worlds drift in silence. Before we set off, I'd love to know, where in the world are you watching from tonight? It's always a joy to imagine these tiny distant planets being explored by minds scattered all across our own. If you find peace in these quiet journeys through space, a like on this video and a gentle tap on subscribe would mean the world. And if you're already part of this little sleepy community, thank you, truly. I do hope this video doesn't become so interesting that it keeps you awake. Though if it does, at least you'll be drifting off with a head full of new cosmic wonders. So shall we begin? After all, what secrets might be waiting out there among the forgotten planets? When most people picture the solar system, they imagine the great parade of planets circling the sun like clockwork. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Beyond them, the light fades, the warmth disappears, and for many the story seems to end. But the truth is that our solar system does not stop at Neptune's orbit. It stretches on for billions of kilometers, dissolving into a quiet realm of icy worlds that almost no one remembers. Here, in the shadows, lie the forgotten planets. Some are small and round, others oddly shaped, all of them ancient. They orbit so far from the sun that their days last longer than our lifetimes, and the sunlight that reaches them is as faint as moonlight on a winter night. They were born from the same swirling disk of dust that gave rise to the great planets, yet they never grew large enough to join their ranks. For centuries, astronomers overlooked them entirely. Their light was too weak, their paths too slow, their stories too quiet. Even when they were finally discovered, many were soon stripped of their planetary titles and filed away as minor bodies, as though their place in the solar system's story had been erased. But each of these forgotten worlds holds clues to how our cosmic neighbourhood was built. Clues locked in ice and stone, waiting patiently in the dark. They are the fossils of planet making, the remnants of worlds that almost were. Their orbits are stretched like elastic bands, looping in slow motion around the sun. Some carry faint atmospheres, others have tiny moons, and a few are still geologically alive, quietly reshaping themselves in the dark. Over the course of this journey, we'll visit these distant and neglected worlds one by one, from the icy heart of the asteroid belt to the mysterious frontier beyond Pluto. We'll see how they formed, what secrets they keep, and how even the smallest, faintest planets can change the way we understand the solar system. And as we wander through their silence, we might find something else too, a reminder that even the most overlooked places can still hold entire worlds of wonder. Between Mars and Jupiter, in a quiet band of space strewn with shattered stone, drifts a world that most people forget exists. It is small, dim, and silent, yet it once held the title of planet. This is Ceres, the largest object in the asteroid belt and the only dwarf planet within the inner solar system. While the great planets whirl and shine, Ceres simply waits, unhurried and unassuming, like a secret someone left between the pages of a very old book. Ceres was first seen on the very first night of a new century in the year 1801. Giuseppe Piazzi, an Italian astronomer, had been cataloguing stars when he noticed something that moved. Night after night, it crept slowly across the blackness. He thought he had found a new planet, and for a while, so did everyone else. For decades, schoolbooks listed Ceres alongside Mars and Jupiter as a true planet. But then more and more small worlds began appearing nearby: Pallas, Juno, Vesta, until Ceres seemed less like a planet and more like the largest pebble in a cosmic gravel path. By the mid-1800s, it had been quietly demoted to an asteroid, and its name faded from public memory. Yet Ceres is not just another lump of rock. It makes up almost a third of the entire mass of the asteroid belt. If the asteroid belt were a kingdom, Ceres would be its quiet queen. Its surface gleams faintly, brighter than its neighbours, and this brightness hints at something remarkable: ice. Unlike most asteroids, Ceres contains vast amounts of water locked in its crust. Some scientists believe that beneath its dusty surface lies a hidden ocean of briny liquid water, salty, cold, and ancient. There are places on Ceres where this hidden ocean may have reached the surface. When NASA's Dawn spacecraft arrived in 2015, it saw something unexpected: dazzling white spots scattered across a crater called Quaoar. They shimmered like frost under the dim sunlight. Later, scientists discovered they were deposits of sodium carbonate, a kind of salt left behind when salty water seeped up from below, froze, and evaporated. These bright patches are like whispers from the planet's interior, hints that even here, in the quiet heart of the asteroid belt, something still stirs. Ceres may even have cryovolcanoes, volcanoes that do not erupt molten rock, but instead ooze cold slurries of salty water and mud. The largest mountain on Ceres, Ahuna Mons, rises like a lonely white pyramid from the dark plains. It looks young, geologically speaking, suggesting it may have formed only a few 100 million years ago. That might sound ancient, but in planetary terms it is almost recent. Ahuna Mons might be the frozen echo of an icy eruption, a reminder that Ceres is not quite as still as it seems. Day on Ceres is a quiet affair. The sun here is faint and far, casting only a pale glow. Shadows are long and soft, and the temperature never climbs above -30 degrees Celsius. At night the stars blaze sharp and steady, undimmed by any atmosphere. There is no wind to stir the dust, no sound to break the silence. The only motion is the slow drift of micrometeorites tapping the surface like ancient clockwork. Its gravity is gentle, only about 3% of Earth's. A single step would carry you forward like a soft leap. If you dropped a pebble, it would take several seconds to reach the ground. Nothing happens quickly here. Everything drifts, everything lingers, and yet despite its stillness, Ceres is a bridge. It sits between two worlds, the rocky inner planets, forged of metal and stone, and the gas giants beyond, swollen with hydrogen and ice. Some scientists think Ceres may be a leftover building block from the dawn of the solar system, a planetesimal that never grew up. If Jupiter had not formed so quickly and so massive, perhaps Ceres would have gathered enough material to become a true planet. Instead, it remained small, a half-finished world caught between two realms. This halfway nature makes Ceres precious. It carries clues about the ingredients that once swirled through the early solar system, the same ingredients that built Earth. Its water, its salts, and its carbon compounds are the same basic materials that life depends on. Billions of years ago, comets and objects like Ceres may have delivered much of Earth's water. In a sense, without quiet little worlds like Ceres, there might never have been oceans or rivers or the sound of rain. There is also something quietly poetic about its orbit. Ceres circles the sun every 4.5 years, slowly, steadily, like a soft pendulum in the dark. It does not race, it does not flare, it simply endures. While planets bustle through their fast-spinning days and moons are locked in perpetual tides, Ceres just glides on in silence, untouched by hurry. If you could stand on its surface, the sun would appear no brighter than a distant lantern. Earth would be a pale blue star hanging in the velvet black, far away and almost delicate. There would be no sound but your own heartbeat inside your suit, no rustling air, no echo, only the slow curve of the horizon beneath your feet, the blackness of space pressing in above, and the comforting knowledge that this small world has held its lonely post for billions of years. Perhaps that is why Ceres feels less like a planet and more like a memory of what the solar system once was and what it might have been. Not grand, not showy, just quietly enduring. It has seen the rise of planets, the dance of comets, the swirling chaos of birth, and it has simply remained. While the giants grew and the inner worlds bloomed with life, Ceres stayed in its silent orbit, halfway between everything, forgotten by most but never gone. Far beyond Neptune, in the quiet expanse of the Kuiper belt, there spins a world that looks as though it has been stretched by invisible hands. Haumea is no ordinary sphere like the planets you know. It is an elongated, oval-shaped dwarf planet, more like a cosmic rugby ball in a globe. And it spins. It spins so fast that its shape has been pulled wide and thin, as if it is constantly trying to fling itself apart, yet never quite manages to escape its own gravity. Haumea completes one full rotation every 4 hours. That is faster than any other large object in the solar system. Earth takes 24 hours to turn once, but Haumea blurs around 6 times in that span, dizzy and determined. If you could stand on its surface, the horizon would be rushing away beneath your feet. You might even feel lighter at the equator than near the poles, because the rapid spin throws outward like a gentle slingshot. This extreme speed is what flattened it into an ellipse, giving Haumea its strange, stretched appearance. Scientists think this furious spin might be the result of a violent collision long ago. In the early days of the solar system, when everything was still forming, objects collided often, smashing together like slow-motion billiard balls. One such impact may have struck Haumea off-centre, setting it spinning so fast that it stretched into the shape we see today. That ancient collision may also have knocked pieces off, which could explain something else unusual about this distant dwarf planet. It has company. 2 small moons circle Haumea, named Hiaka and Namaka, after daughters of the Hawaiian goddess from whom Haumea takes its name. They are tiny compared to their parent, more like glittering shards than worlds, but they keep faithful watch as Haumea hurtles through the darkness. Their orbits are slightly tilted and dance in slow rhythm with their elongated world, like little companions caught in the wake of a whirling ice skater. And there is something even stranger still. Haumea has rings, thin, dark, delicate rings, orbiting about 1,000 kilometers above its surface. This makes it one of only a handful of known objects beyond the gas giants to wear such adornments. The rings are thought to be made of rock and ice, probably debris from that same ancient impact, slowly circling in a graceful loop. Seen from afar, the whole system, Haumea, its rings and its moons, must look like a shimmering spinning jewel drifting at the edge of the sun's reach. Its surface adds to the mystery. Haumea reflects sunlight better than almost anything else out there, its brightness second only to freshly fallen snow. It shines with an icy silver gleam. Spectral studies suggest that the surface is coated in crystalline water ice, constantly renewed, possibly from the outgassing of buried material or the grinding of ice particles as the planet spins. This shiny skin makes Haumea look younger than it really is, like an ancient dancer wearing a mirror-bright costume. Beneath that sparkling exterior, Haumea is probably a mix of rock and ice. Its density hints at a rocky core wrapped in a thick, icy shell. Some scientists even speculate that there might be pockets of liquid water deep within, though at such distances and low temperatures, any warmth would be fleeting and precious. The sun out here is a faint ember, and light takes nearly 6 hours to reach this world. Haumea exists in a realm where time moves slowly, yet it refuses to match that pace, spinning frenetically while everything else drifts like frozen statues. Because of this unusual speed and shape, Haumea has captured imaginations. It is sometimes called the cosmic fidget spinner, a nickname that sounds playful but hints at just how rare it is for a large world to be so restless. Most planets find balance and settle into near-spherical shapes under their own gravity, but Haumea resists this calm. It has made itself an exception, an oddity, a glittering blur against the black velvet of space. Its orbit carries it far beyond Neptune, taking about 284 Earth years to complete one circuit around the Sun. During that long journey, It spends most of its time frozen in the deep Kuiper belt, surrounded by countless other icy remnants from the solar system's formation. Yet Haumea stands out among them, not just for its size, which rivals Pluto's in width if not in mass, but for its defiance of expectation. It looks like it should not work, and yet it does. Imagine standing on its surface, though standing might be optimistic. Gravity here is weak, about 1/12 of Earth's, and the rapid spin would make your balance feel unsteady. The ground would curve strangely away to the sides, and as Haumea turned beneath you, the sun would dart across the dim sky in a quick loop every 4 hours. Long shadows would slide by like clock hands, and the 2 tiny moons would appear to whirl around you far faster than the moon back home. The silence would be absolute, broken only by the whisper of your own breath. There is something quietly thrilling about a world so far from the sun spinning with such determination. While almost everything else out here drifts in frozen slowness, Haumea twirls like a secret dancer. It does not shine brightly. It does not roar with storms like Jupiter or blaze with rings like Saturn. It simply spins, fast and fearless, wearing its glittering coat of ice and its delicate ring, carrying its 2 small moons as if they were ornaments on a carousel. Haumea reminds us that the solar system is not uniform. Not every world chooses stillness. Some decide to whirl, some keep their secrets close, tucked into their cold surfaces, spinning silently as the centuries slide by. Out here, where the sun is a pale dot and the stars are hard and sharp against the black, Haumea spins on, a silver blur in the darkness, a frozen ellipse that refuses to stop. Far out in the Kuiper belt, where sunlight is little more than a pale memory, drifts a tiny reddish world with a name that sounds like a soft echo, Makemake. It is small, distant, and quiet, yet it holds a curious place among the frozen remnants of the early solar system. Its very name carries a hint of whimsy. Makemake was discovered around Easter in the year 2005, and the team who found it chose to name it after the creator god of the Rapa Nui people of Easter Island. The name is pronounced Makemake, a gentle rhythm that fits the world's serene nature. Makemake is only about 2/3 the size of Pluto, making it one of the smaller known dwarf planets. Still, in the cold expanse where it drifts, it stands out. Most of the Kuiper belt is filled with small dark objects that barely reflect any light, yet Makemake glows with a subtle reddish sheen, like old copper catching starlight. Through powerful telescopes it appears as a faint dot, but that dot carries stories older than the planets themselves. Its surface is coated in frozen methane, ethane, and nitrogen, lying in layers like delicate frost. Temperatures out here plunge to around -200 degrees Celsius, cold enough to freeze even gases into solid ice. Over unimaginable stretches of time, the harsh radiation from the distant sun has altered these frozen gases into complex organic compounds called tholins. Tholins are not alive, but they are thought to be some of the building blocks from which life's chemistry might have begun. They form when ultraviolet light and cosmic rays strike simple molecules like methane, rearranging their atoms into dark, sticky organics. On Makemake, these tholins tint the surface a rusty red, giving the world its distinctive colour. This soft red hue is more than just decoration. It is a signpost of time. It hints that Makemake's surface has lain undisturbed for millions, perhaps billions of years, slowly darkening under the steady drizzle of radiation from space. Every grain of frost has a history. Every crimson stain is the shadow of ancient sunlight. If you could scoop up a handful of this surface material, it would likely crumble like frozen dust, faintly glimmering as it caught the dim light from the sun. Makemake also has an atmosphere, though calling it that might be generous. It is incredibly thin, more like a ghost of air than a sky. When Makemake is closest to the sun in its elongated orbit, frozen methane and nitrogen at the surface can sublimate directly into gas, forming a delicate veil. As it moves farther away again and the temperature drops, this thin mist collapses back onto the surface as frost. This fragile atmosphere comes and goes like a sigh, invisible and fleeting, a reminder that even the stillest places are never truly still. In 2016, astronomers made a surprising discovery. Makemake has a tiny moon. It is only about 175 kilometers wide, and it circles so close to Makemake's bright glare that it had escaped notice for years. This moon has been nicknamed MK2 for now, though it will likely receive a proper mythological name in the future. The moon's presence could help scientists measure Makemake's mass more precisely, and by watching its orbit they can estimate the density and internal structure of this distant red ice ball. Even in the silent dark, Makemake is not entirely alone. Makemake's orbit carries it around the Sun once every 305 Earth years. Light from the Sun takes more than 7 hours to reach it. Out there, the Sun would look like a small blinding star rather than the broad disk we see from Earth. The days are long and lethargic, and the nights are endless stretches of glittering black. There is no atmosphere thick enough to blur the stars, so they would hang sharp and steady above, like tiny diamonds scattered across velvet. If you could stand on its surface, you would find yourself in a world of delicate contrasts. The ground beneath your feet would be red and dark, yet sparkling with icy grains. Each step would feel like walking on compact snow, and the lack of gravity, only about 7% of Earth's, would make your steps bounce as though in slow motion. The silence would be complete. No wind, no rustle, just the sound of your own breath and the faint creak of your boots. Your shadow would stretch long and clear across the frozen plains, a silent companion under the pale sun. Makemake's discovery was more than just finding a new dot in the sky. It was part of a revolution. When astronomers found Makemake, along with other icy worlds like Eris and Haumea, they realized the solar system was more crowded than they had imagined. These discoveries challenged the old definitions of what a planet should be, eventually leading to Pluto's reclassification as a dwarf planet. Makemake itself is now one of the 5 officially recognized dwarf planets, standing quietly as proof that the solar system did not end with Neptune. It just got quieter. What makes Makemake captivating is how unassuming it is. It does not have Saturn's rings or Jupiter's storms. It does not glow with volcanic heat or roar with atmosphere. It simply drifts, a cold red ember floating in darkness. And yet, its surface may hold the chemistry that helps seed life on Earth. Worlds like Makemake are like cosmic time capsules, preserving the raw materials from the dawn of the solar system. They show us what the building blocks of planets looked like before they were gathered up, baked and reshaped. Even its name adds to its charm. The Rapa Nui god Makemake was a creator, a bringer of life, a figure of renewal. It feels fitting that this distant dwarf planet carries that name. It too may carry the ingredients for creation, locked in its frozen crust, waiting out the ages. The idea that something so small and quiet could hold such profound secrets is a comforting thought, that even the most overlooked places can be keepers of beginnings. Makemake is a reminder that the solar system is not just made of the loud and the large. It is also built from whispers. It is shaped by tiny frozen spheres that wander far from the sun, worlds so cold and so still that they seem timeless. They do not roar with weather or glow with lava, yet they endure. Makemake glides on through the Kuiper belt, red and silent, spinning slowly beneath the sharp stars, carrying the memory of the solar system's first days across the dark. Far beyond Neptune, where sunlight fades to a pale ghost and the stars seem sharper against the dark, there drifts a world that quietly reshaped our understanding of the solar system. Its name is Eris, and though it is slightly smaller than Pluto, it is more massive, dense, cold, and unyielding. Eris may be distant and silent, but when it was discovered, it caused an uproar that echoed all the way down to Earth's classrooms. Eris was first spotted in the year 2005 by a team of astronomers led by Mike Brown at the Palomar Observatory in California. At first, they thought they had found the 10th planet. It was bright, it was far, and it was large enough to rival Pluto. For decades, Pluto had been considered the solar system's odd little outer planet, and this new world seemed ready to join it, or even surpass it. When the first size estimates for Eris came in, some suggested it might be bigger than Pluto. That idea set off a chain reaction of questions that had quietly lingered in astronomy for years. What exactly counts as a planet? If Pluto was small enough to be reconsidered, and Eris was about the same size, or perhaps even bigger, should there be 10 planets now? Or 12? Or dozens? Astronomers began to realize that if Pluto counted, then Eris and many other icy worlds in the Kuiper belt might also have to count. The neat list of 9 planets that children had memorized for generations suddenly looked fragile, like an old map being peeled apart by new discoveries. In 2006, the International Astronomical Union gathered to settle the debate. They created a new definition of the word planet, and in doing so, they reshaped the solar system's family tree. To be called a planet, they declared, an object must orbit the Sun, be large enough for gravity to pull it into a nearly round shape, and have cleared its orbit of other debris. Pluto and Eris met the first 2 conditions, but failed the third. They had not swept their neighbourhoods clean. They shared their orbits with countless other icy bodies, and just like that, Pluto was reclassified as a dwarf planet, and Eris was placed in the same new category. This decision sparked outrage among the public. People had grown fond of Pluto, the tiny underdog at the edge of the solar system. It had weathered decades of obscurity only to be stripped of its status. Eris, though innocent in all this, was blamed by many as the planet that killed Pluto. Headlines declared a 10th planet had been discovered and then demoted, while Pluto had been kicked out of the Planet Club. Children wrote letters to astronomers asking how they could do such a thing. Some suggested naming Eris Persephone after the queen of the underworld, since she had dragged Pluto down. In the end, the name chosen was Eris, the Greek goddess of strife and discord, a nod to the turmoil her discovery had unleashed. Ironically, Eris herself could not be less dramatic. She's a quiet, frozen world about 2,320 kilometres across, just slightly smaller than Pluto, but she is denser, made of more rock than ice, which makes her about 27% more massive. She orbits the Sun at an average distance of over 10 billion kilometres, taking 557 years to complete one circuit. At her most distant, she is nearly 3 times farther from the Sun than Pluto ever goes. Out there, sunlight is incredibly weak. It takes nearly 9 hours for light from the Sun to reach Eris. The warmth that reaches her is so faint that her surface is locked in eternal frost. Temperatures hover around minus 230 degrees Celsius. The surface is likely covered in nitrogen ice with patches of frozen methane, glinting faintly like frost in starlight. This ice reflects sunlight efficiently, making Eris one of the brightest objects in the Kuiper belt. Through a telescope, she shines like a tiny jewel, cold, distant and stubbornly steady. Eris also has a moon, named Dysnomia, after the goddess of lawlessness and the daughter of Eris in Greek mythology. Dysnomia is about 350 kilometres wide and orbits Eris at a leisurely distance of 37,000 kilometres. Watching Dysnomia's orbit allowed astronomers to measure Eris's mass precisely, confirming that this small world outweighed Pluto despite its slightly smaller size. Together they drift like a frozen pair turning silently in the far dark. There is something quietly haunting about imagining Eris up close. The sun would be no brighter than a sharp white star. The sky would be black even at noon, scattered with crisp constellations. The ground would be hard as stone, glazed with pale frost that crunches underfoot like glass. Gravity would be weak, only about 8% of Earth's, so each step would feel more like a careful bound. There would be no sound but your own breathing, no breeze, no hint of warmth. Eris is a place where time seems to hold its breath, and yet, despite this stillness, Eris reshaped the solar system without ever meaning to. Its discovery forced humanity to look more carefully at the rules we use to label the cosmos. It reminded us that our categories are human inventions, while the universe simply is what it is. Eris did not set out to dethrone Pluto. It just existed, quietly circling the sun as it had for billions of years, until our telescopes became sharp enough to notice. The choice of her name seems fitting in hindsight. Eris the goddess was said to sow discord wherever she went, and this small world certainly lived up to that. But there is a kind of gentle humour in the chaos she caused. Imagine drifting peacefully in the deep black for eons, minding your own icy business, only to be spotted and immediately start an argument among humans 90 times closer to the sun. Eris may be silent, but she has a knack for stirring things up without lifting a frozen finger. Today, astronomers view her less as a troublemaker and more as a clue. Eris is part of the scattered disk, a region beyond the Kuiper belt filled with objects on wildly tilted and elongated orbits. These worlds may have been flung outward by Neptune's gravity long ago, or jostled by passing stars in the sun's infancy. Studying Eris could help unravel how the outer solar system took shape, and why some objects stayed close while others were cast into the cold. Eris stands as proof that size is not everything. It is small, yes, but powerful enough to change how we think. It forced scientists to admit that the solar system is more complex than a tidy list of 9 familiar names. There are thousands of worlds out there, many still unseen, quietly orbiting in the dark. Eris is just the one that finally made us notice. In the end, there is something oddly comforting about her. She may have caused turmoil among astronomers, but she is utterly indifferent to our arguments. She continues her frozen circuit, bright and silent, far beyond the planets that once ignored her. While the debate fades into history, Eris glides on, steady and serene, the little world that reminded us how much wonder still waits beyond the edge of what we thought we knew. Far beyond the Kuiper belt, past even the scattered edge where the sun's gravity begins to loosen its hold, drifts a world so distant that its orbit spans almost the entire architecture of the solar system. Its name is Sedna, and it is one of the most remote objects ever discovered circling our sun. While the familiar planets make neat loops measured in years, Sedna traces a path so vast that it takes about 11,400 Earth years to complete a single orbit. Civilizations could rise and fall, mountains could erode into dust, and Sedna would still be crawling along her path, silent and unchanged. Sedna was discovered in the year 2003 by a team of astronomers led by Mike Brown. At first, they were stunned not by its size, it is only a bit smaller than Pluto, but by its sheer remoteness. Even at its closest approach, Sedna never comes nearer to the Sun than about 76 astronomical units. For comparison, Neptune orbits at about 30. At its farthest, Sedna drifts more than 900 astronomical units from the Sun, nearly 100 times farther than Earth. From such a distance, the Sun is not a blazing disk, but a sharp pinprick of light, barely brighter than the other stars. Its discovery challenged what scientists thought they knew about the solar system's boundaries. Sedna's elongated path does not fit with the Kuiper belt, where most icy bodies orbit in a flattened ring beyond Neptune. Instead, it seems to belong to a different, more distant realm, possibly the innermost edge of the hypothetical Oort cloud, a vast spherical shell of icy bodies that may surround the solar system, like a ghostly halo. If Sedna is truly part of this inner Oort cloud, it would be the first known object from that mysterious reservoir, a lone ambassador from the deep freeze. Its surface is a rich, dark red, the colour of ancient, irradiated organic matter. Sedna is one of the reddest objects in the entire solar system, even redder than Mars. This colour likely comes from tholins, the same complex organic compounds that give Makemake and Pluto their hues, but here they have been baked by cosmic rays for billions of years without disturbance. Over time, the radiation has transformed simple ices into dense tar-like layers that stain the surface. The redness of Sedna is not a fresh blush, but the deep tone of immense age, a cosmic rust that speaks of eternity. Temperatures here plunge to around minus 240 degrees Celsius. Nitrogen and methane, which are gases on Earth, are locked solid as rock-hard ice. Any atmosphere Sedna might once have had has long since frozen out and fallen back to the surface in faint layers of frost. The airlessness leaves the stars painfully sharp above, and the silence is absolute. No wind, no sound, no warmth. Just the slow, steady fall of sunlight weakened to almost nothing. If you could stand on Sedna, the sun would appear no larger than a bright star. Shadows would be crisp and infinite, stretching across reddish plains that glow dully under the weak light. The gravity would be gentle, about 5% of Earth's, and every step would feel like walking through a dream where the ground does not quite hold you down. Time would seem suspended. Days and nights would blend into a long twilight, and the sky would be a black ocean of stars unmoving in their clarity. Sedna's remoteness raises tantalizing questions. How did it end up on such a wild, stretched orbit? One possibility is that long ago, a passing star brushed past the young solar system, tugging Sedna outward like a loose thread. Another idea is that an unseen giant planet, sometimes called Planet 9, lurks far beyond Neptune and gently shepherded Sedna into its strange path. Or perhaps Sedna formed even farther out, on the icy fringe where the sun's gravity barely grasped, and it has simply been circling quietly ever since, unnoticed until our telescopes became sharp enough to catch it. Whatever its origin, Sedna is a time capsule from the solar system's earliest days. Unlike the planets, it has likely been geologically inactive for billions of years. Its surface records the unbroken history of cosmic weathering, like an ancient library carved from frozen stone. Each crater, each ridge, is a page from an era when the sun was young and the planets were still forming. To look at Sedna is to peer backward in time, not just centuries but nearly the full age of the solar system itself. Its sheer slowness is part of its strange beauty. While Earth spins through a year in 365 days, Sedna takes 11,400 years to finish a single loop. To put that in perspective, when Sedna last passed near the sun, mammoths still walked the Earth, and the first human cave paintings were only beginning to appear. By the time it swings close again, humanity as we know it may be entirely different, or perhaps not here at all. Sedna travels on a timescale so vast that human history seems like a spark against its endless night. This immense sense of time makes Sedna feel almost outside the solar system, like a drifting thought rather than a planet. It circles the sun, yes, but so slowly that its motion is invisible to the eye. Decade by decade, century by century, it glides through darkness, untouched and unbothered by the hurried drama of the inner worlds. Even Pluto, with its long 248-year orbit, seems like a sprinter compared to this red wanderer. Sedna's existence reminds us that the solar system is not a tidy clockwork of neatly spaced orbits. It is messy, stretched, and wild at the edges. There are objects so far away that sunlight arrives only as a whisper, so cold that time itself seems frozen with them. They are not part of our daily sky. They are part of the solar system's memory, the forgotten echoes of its creation still drifting at the border of interstellar space. And yet, there is something quietly comforting about Sedna's endurance. While planets bustle with storms and geology, while comets flare briefly and vanish, Sedna endures unchanged. It is a steadfast ember in the dark, glowing faintly red as it makes its long pilgrimage around the sun. It does not hurry, it does not compete, it simply continues. In that way, Sedna is almost like the concept of time itself, slow, patient, unstoppable. It asks nothing and gives nothing except the reminder that the universe is vast beyond imagining and old beyond words. As we trace its path across the black, we are reminded how fleeting we are, and how wondrous it is that our brief lives can reach out across billions of kilometers to glimpse this faraway world. Sedna carries the quiet dignity of distance. It will not be visited soon. It may never be visited at all, but it does not need our presence to be real. It spins alone under the thin light of the distant sun, a solitary red bead on a thread of frozen space waiting out the ages. While we count years, Sedna counts millennia, and to her they are nothing more than the passing of a moment. Far beyond Neptune, in the dim outer reaches of the Kuiper belt, there is a world that moves in a quiet dance of symmetry. It is called Orcus, and it is often nicknamed the anti-Pluto. The name is not a slight. It is a description of its strange, perfectly balanced orbit. While Pluto travels around the Sun in a looping, tilted path, Orcus follows almost the same path, but on the opposite side of the solar system. When Pluto swings close to the Sun, Orcus is farthest away. When Pluto is far out in the cold, Orcus drifts inward. The two never meet, forever bound in a silent seesaw motion, like cosmic partners who will never cross paths. This orbital relationship is known as a resonance. Both Pluto and Orcus are locked in what is called a 2-to-3 resonance with Neptune. For every 2 orbits Pluto or Orcus completes, Neptune completes exactly 3. This delicate gravitational pattern keeps them from colliding with the giant planet, like clockwork pieces moving in perfect timing. Orcus's position is always roughly opposite Pluto's, which is why it earned its nickname. It is Pluto's mirror, its shadow twin, tracing the same cosmic dance steps but always on the other side of the stage. Orcus was discovered in the year 2004 by a team led by Michael Brown, Chad Trujillo and David Rabinowitz. At first it was just a faint moving dot among the stars, but further observations revealed its size and orbit. It is about 910 kilometers across, roughly half the diameter of Pluto, and made mostly of ice mixed with rock. While not large enough to qualify as a dwarf planet yet, it sits right on the threshold. If it proves to be spherical under its own gravity, it may someday join that quiet club of recognized worlds. Its surface is dark, reflecting only about 20% of the sunlight that hits it. This suggests that the ice has been darkened by long exposure to cosmic rays, which slowly break down simple molecules and leave behind complex organics called tholins. These tholins stain the ice a deep brownish grey, giving Orcus the look of an ancient frozen ember. Like many outer worlds, it carries water ice, methane and carbon compounds locked in its crust, silent remnants from the earliest days of the solar system. Orcus is not alone out there. In 2005, astronomers discovered that it has a moon named Vanth. The name comes from Etruscan mythology. Vanth was a winged spirit who guided souls to the underworld, a fitting companion for a world named after Orcus, the Etruscan god of the dead. Vanth is about 475 kilometers across, nearly half the size of Orcus itself, which makes it unusually large compared to its primary. Because of this, some scientists even consider Orcus and Vanth to be a binary system, 2 worlds orbiting a shared centre of gravity like a slow, frozen dance. Vanth appears much redder than Orcus, hinting that its surface composition is different. Perhaps it formed from a giant collision long ago, or perhaps it was captured from elsewhere. Either way, the pair is locked together in a gravitational embrace, turning silently as they orbit the Sun. If you could hover nearby, you would see Vanth gliding around Orcus every 10 days, a rusty pearl orbiting a dark grey stone, with the distant Sun shining faintly behind them like a lonely lantern. Seasons on Orcus are strange. Its orbit is tilted, and its axis may be tilted as well, which means its poles could spend centuries bathed in dim sunlight, followed by centuries of darkness. Imagine one pole locked in a soft twilight for hundreds of years, while the other freezes in unbroken night. This slow cycle means that ice on its surface may slowly migrate from pole to pole over millennia, sublimating in the weak warmth and refreezing in the dark. Even time itself feels heavy and deliberate here, measured not in days or years but in epochs. Temperatures are brutally cold. Orcus lies about 6 billion kilometres from the sun, and the weak sunlight barely warms its surface to more than minus 200 degrees Celsius. Its thin crust of frozen volatiles likely hides a rockier interior. Some scientists suspect there might even be a layer of slushy water buried deep inside, kept from freezing solid by residual heat from long ago or by the tug of Vanth's gravity. If so, Orcus could be quietly holding a hidden ocean, a tiny echo of warmth sealed beneath its ancient ice. Despite its darkness and distance, Orcus is surprisingly bright through a telescope, which helped astronomers track its motion precisely. Its path shows the elegant choreography of orbital resonance, a perfect rhythm that has lasted for billions of years. While Pluto has captured the world's imagination with its heart-shaped plains and close-up portraits from spacecraft, Orcus remains a mystery, a silent twin seen only as a glimmering dot. And yet, there is something soothing about its restraint. It does not clamour for attention. It simply glides through space with patient precision. Its name suits it. In Roman and Etruscan mythology, Orcus was a quiet god of the underworld, not as flamboyant as Pluto or Hades, but just as inevitable. He was said to wait silently, never chasing souls, but always being there at the end. That same quiet inevitability seems woven into the world that bears his name. Orcus does not blaze or roar or boast. It moves in harmony, steady and sure, the calm counterpoint to Pluto's drama. If you could stand on its surface, you would see Vanth hanging enormous in the sky, almost half as wide as your horizon. The stars would blaze sharp above, unmoving, while the sun would appear no brighter than a fierce distant star. Each step you took would be slow and light, thanks to the weak gravity, only about 1/10 of Earth's. The ground would be dark and crusted with ancient frost. Nothing would stir. Even your shadow would feel heavy, as though reluctant to move. There is something deeply peaceful about the idea of Orcus. In a solar system full of chaos, it offers balance. While Pluto races through its orbit with its heart-shaped plains and its dramatic history, Orcus simply mirrors it, keeping perfect time from the other side. It is the quiet twin, the shadow dancer, the patient one. In that way, Orcus reminds us that not every part of the cosmos seeks attention. Some worlds are content to stay in the background, moving with grace rather than spectacle. They are the steady beats in the universe's rhythm, the soft counter-melody beneath the loud themes. Orcus drifts in that role perfectly, dark, slow and balanced, orbiting in eternal opposition to Pluto as if the two are halves of a hidden symmetry. While the outer solar system holds many strange and wild objects, few are as calming as Orcus. It does not defy gravity or rush through space. It simply keeps its place, holding its rhythm across the ages. Like a pendulum swinging in deep space, it reminds us that even in the most distant cold, there can be harmony, a quiet balance that endures long after everything else has changed. Out beyond Pluto's path, where the sun glows no brighter than a distant lamp, drifts a quiet world with a name that often tangles on tongues, Quaoar. It looks like it should rhyme with jaguar, and many people pronounce it that way, but the correct way is softer, more musical, Quaoar. The name comes from the Tongva people of what is now Southern California, who spoke of Quaoar as a creative force, a spirit who sang the world into being. It is a fitting name for a world that seems to hum along gently at the edge of the solar system, not loud or flashy, but steady, enduring, and oddly elegant. Quaoar was discovered in the year 2002 by astronomers Chad Trujillo and Michael Brown, who noticed a faint point of light slowly drifting against the background of stars. At the time, it was one of the largest known objects beyond Pluto, and it hinted that the outer solar system might be far more crowded than anyone had imagined. Quaoar measures about 1,100 kilometers across, making it larger than Ceres, and it carries enough gravity to shape itself into a nearly round form. This alone sets it apart from most of the small, irregular icy bodies that fill the Kuiper belt. Its surface is dark, reflecting only about 10% of the sunlight that strikes it, yet it is not dull. Spectral studies suggest that it is coated with a mixture of water ice, frozen methane, and dark organic compounds known as tholins. These tholins are born from radiation breaking apart simple ices over billions of years, leaving behind reddish-brown stains that colour Quaoar's crust like ancient varnish. The water ice glints faintly through this dark coating, hinting that the surface is not entirely old. Something may occasionally refresh it, perhaps slow cryovolcanic activity or the impact of small objects. Intriguingly, Quaoar may hold water in a much more exciting place, beneath its surface. Some scientists suspect that deep inside this quiet world could be a layer of slushy liquid water, insulated by the surrounding ice, and kept from freezing by the heat of radioactive elements in its rocky core. This would make Quaoar part of a growing list of small outer solar system bodies that might hide underground oceans, quietly cradling liquid in places where the sunlight is too faint to keep anything warm. It is only speculation for now, but the idea that something so far away, so cold, might still hold liquid water is quietly astonishing. In 2023, Quaoar revealed another surprise. It has a ring. This thin, delicate ring orbits about 4,000 kilometers above its surface, far farther out than scientists expected such a structure could survive. Usually rings only remain stable within what is called the Roche limit, the distance where a planet's gravity tears apart any object that tries to clump together. Quaoar's ring lies well outside this limit, which means it should have collapsed into a small moon long ago. Somehow it has resisted doing so, and no one is quite sure why. Perhaps the icy particles are held in place by subtle resonances, or by the faint gravitational influence of a small unseen moonlet shepherding them like a cosmic sheepdog. Whatever the reason, the ring gives Quaoar a delicate, ethereal grace, like a faint halo of frost circling in the dark. Quaoar itself moves slowly and steadily around the Sun, taking about 286 Earth years to complete a single orbit. It drifts just beyond Pluto's path, gliding through the Kuiper belt like a quiet dancer keeping her own tempo. There is nothing hurried about its motion. Each revolution is measured in centuries, and each season likely lasts for decades. The thought of its rhythmic path is strangely soothing, like watching the steady swing of a pendulum that has been moving since before humans first looked up at the stars. If you could stand on Quaoar, the sun would be no brighter than a sharp star, and the ground beneath your boots would be dark and faintly glimmering with frost. The gravity would be gentle, about 1/12 of Earth's, and every step would carry you in long floating arcs. The sky would be jet black, dotted with hard, unwavering stars, and if you looked closely, you might see the faint glimmer of its ring, a pale thread of ice particles encircling the horizon. The silence would be absolute. No wind, no sound, just the soft crunch of ancient ice underfoot and the slow tick of your own heartbeat. Quaoar is one of those worlds that seems content not to be noticed. It does not announce itself with dramatic storms or glowing plumes or crashing impacts. It simply endures, orbiting in patient loops while the sun burns and fades, while planets spin and comets flare. And yet, this quiet endurance is part of what makes it remarkable. Worlds like Quaoar are the building blocks that never quite built. They are the raw material left over from the solar system's earliest days, frozen in time, still carrying the whispers of how planets begin. Its name adds to its gentle character. The Tongva people said that Quaoar danced and sang the first beings into existence, shaping order from chaos with music. That image of a world that sings quietly in the dark feels oddly fitting. Quaoar does not crash or roar. It glides, humming a tune too slow for human ears, yet steady enough to last through millennia. Even the discovery of its ring seems like a verse from that song, a delicate note hanging in space, suspended far longer than anyone expected. There is a quiet satisfaction in knowing that such a world exists. In the vast cold of the outer solar system, where sunlight weakens and time stretches thin, Quaoar spins gently, ringed and resilient. It is larger than Ceres, older than recorded history, and still serene. If planets were personalities, Quaoar would be the reserved one in the corner. Calm, graceful, a little mysterious, and perfectly content to let others take the spotlight. And yet, for all its modesty, Quaoar reminds us of something profound, that beauty does not require grandeur. Sometimes it lies in steadiness, in patience, in the slow, unhurried turning of a small world around a distant sun. Quaoar does not demand attention. It simply exists, quietly magnificent, tracing its long path like a soft waltz across the darkness, a gentle giantlet with a frozen halo glowing faintly in the eternal night. Far out in the dim Kuiper belt, where the sun is little more than a sharp glimmer in the black, there drifts a small crimson world named Gonggong. It moves slowly, almost shyly, along a tilted path that slices diagonally through the flat plane where most planets orbit. While the familiar worlds circle the sun like beads on a plate, Gonggong leans at an angle, as if it has chosen its own direction, apart from the rest. It is one of the reddest known objects in the outer solar system, a tiny glowing ember against the darkness, and its lonely wander through deep space has made it one of the most quietly captivating of the forgotten worlds. Gonggong was discovered in the year 2007 by a team of astronomers led by Meg Schwamb, Michael Brown, and David Rabinowitz. At first, it was just a faint, slow-moving speck captured in digital images taken at Palomar Observatory. But its sluggish motion gave it away. It was far beyond Neptune, at a distance of more than 85 astronomical units from the Sun. Over time, as its orbit was calculated, it became clear that Gonggong is a dwarf planet, about 1,230 kilometers across, similar in size to Pluto's icy cousins. Its orbit is peculiar. Gonggong travels on an elongated path that takes it from about 34 astronomical units, at its closest to over 101 at its farthest, and the entire orbit is tilted by more than 25 degrees from the solar system's main plane. It takes over 550 years to make a single circuit around the Sun. This odd slanted path may hint at a violent past. Some astronomers think Gonggong could be the scarred survivor of an ancient collision, knocked into its crooked orbit billions of years ago, when the solar system was still forming and chaos ruled. That ancient violence may also have shaped its colour. Gonggong is a rich, dark red, more so than almost any other large object in the Kuiper belt. This striking hue comes from tholins, complex organic compounds formed when cosmic rays and ultraviolet light bombard icy surfaces over millions of years. On Gonggong, this process seems to have gone further than usual, building up thick layers of reddish-brown material that cloak the surface like ancient lacquer. The result is a world that looks like a tiny frozen ember, glowing faintly red against the endless black. Its surface is likely a mix of water ice, methane ice, and these dark organics. The reddish tone suggests that methane once coated the surface and has slowly broken down under radiation, leaving darker residues behind. Some scientists think this process may still be ongoing, meaning that Gonggong's colour is still deepening even now, pigmenting itself slowly under the pale trickle of distant sunlight. It is like a world quietly painting itself red over the course of eons. Gonggong also has a companion. In 2016, astronomers discovered a small moon circling it. named Xiangliu after a 9-headed serpent from Chinese mythology. Xiangliu is much smaller than its parent, only about 200 kilometers across, and it orbits at a distance of around 15,000 kilometers. Its motion has helped scientists estimate Gonggong's mass, revealing that this small world is denser than pure ice, containing a substantial amount of rock. Some even suspect that Xiangliu may have been born from the same ancient collision that gave Gonggong its tilted orbit, flung out from its crust and later captured into a gentle orbit. The pair now drift together, a red world and its tiny shadow dancing in the dark. Because Gonggong spins slowly, one full rotation every 22 hours, its days are long and still. Seasons are even more extreme. Its tilted orbit and possible axial tilt mean that one pole can face the sun for centuries, while the other lies in frozen darkness. As it creeps through its half-millennium-long year, the sunlight shifts in slow-motion arcs, melting and refreezing the surface ices in sluggish migrations. Somewhere on Gonggong right now, a single sunrise could last longer than the entire history of modern civilization. The temperatures are unimaginably cold, plunging to about minus 230 degrees Celsius. The sun's warmth is so faint here that it cannot even stir the frozen gases on the surface. If Gonggong ever had an atmosphere, it has long since collapsed back to the ground as frost. The stars above it are sharp and unwavering, and the silence is absolute. It is the kind of place where even time seems hesitant to move, and yet, for all its stillness, Gonggong has a certain elegance. It is not chaotic or broken. It is balanced in its own way, gliding smoothly along its tilted path as if unbothered by the rest of the solar system's busy traffic. It moves slowly but steadily, a crimson marble rolling across black velvet. If you could stand on its surface, the sun would be no brighter than a fierce star, and Xiangliu would rise like a dull copper bead in the sky. Your steps would be slow and buoyant, each one lifting you into the weak gravity before settling softly back onto the ancient red frost. There is something quietly compelling about a world that chooses such solitude. Most of the known dwarf planets cluster near the plane of the planets, keeping roughly to the same flattened disk. Gonggong ignores that pattern. It tilts and wanders, taking its own route through the dark, almost as if it is drifting through a separate hidden layer of the solar system. Perhaps that is what makes it feel so mysterious. Not that it is strange in shape or size, but that it simply does not care to fit in. Its name suits that personality. Gonggong is named after a water god from Chinese mythology, a red-haired serpent-like being who was said to have tilted the heavens in anger. It is a poetic choice, a crimson world on a tilted orbit, named for a figure who knocked the sky askew. The name carries a hint of rebellion, of something that will not stay aligned, and Gonggong lives up to it with quiet dignity. It does not rage or blaze, but it does not conform either. It just drifts, leaning forever away from the rest. Like many of the small distant worlds, Gonggong is likely a remnant from the solar system's birth, a leftover piece of the building blocks that never grew large enough to become a planet. It has held its shape through billions of years of collisions, migrations and upheavals, outlasting almost everything that once surrounded it. While the inner planets boiled and erupted and reshaped themselves, Gonggong stayed cold and slow, painting itself red while the cosmos rushed by. There is a quiet kind of beauty in that. Gonggong is not dramatic. It does not demand attention. It is simply there, glowing faintly in the black, orbiting on a slant with its tiny moon in tow. It reminds us that the solar system is not just circles and order, it is also tilts, outliers, and wanderers. It is made of things that do not fit, yet still belong. Somewhere far from the warmth and noise of the inner worlds, Gonggong continues its long journey, spinning softly, dragging its red shadow across the frozen deep. It is a lonely red marble adrift in space, turning on its tilted path as if it has all the time in the universe, because in its quiet way, it does. Far out beyond Neptune, in the icy silence where sunlight fades to a pale glow, the solar system does not end. It frays. Beyond the familiar planets, and even beyond the celebrated dwarf worlds like Pluto and Eris, there is a whole population of small, shadowed spheres drifting through the dark. They are not household names, most are little more than faint pinpricks of light in our largest telescopes. Yet they form a kind of hidden family, an unseen archipelago scattered across the outer deep. Among them is Ceres, a world that quietly circles the sun about 43 astronomical units away. Ceres is named for the Roman goddess of the sea, a fitting title for a world adrift in a vast cosmic ocean. It's about 850 kilometers across, roughly the size of Alaska, and has a small moon called Actaea. Ceres is dark, reflecting only about 4% of the sunlight that touches it, which makes it dim even compared to its distant neighbours. Its low reflectivity suggests its surface is coated in ancient, radiation-darkened ice and organics, untouched for billions of years. Some astronomers think Ceres may have enough gravity to be round, which would make it a dwarf planet in waiting, quietly orbiting beyond Pluto with little fanfare. Then there is Varuna, a slightly smaller but faster spinning world named after an ancient Vedic deity of the oceans and the night sky. Varuna is about 650 kilometers across, and it whirls around on its axis every 6 hours, one of the fastest rotations of any known Kuiper belt object. This rapid spin has stretched it into an oblong shape, like a water balloon tossed in slow motion. Its surface shows signs of water ice mixed with darker carbon compounds, and some scientists suspect that beneath its cold crust may be pockets of slushy material left from its early formation. Varuna is like a tiny frozen top spinning at the edge of the sun's faint reach, fast yet faint, holding together through sheer momentum. Ixion is another member of this distant clan, named after a mortal from Greek mythology, who was bound to a flaming wheel for eternity. Fittingly, Ixion rolls endlessly around the sun at an average distance of about 42 astronomical units, following a path similar to Pluto's. It's about 700 kilometers across and dark reddish-brown in colour, likely stained by the same tholins that paint many of the outer worlds. Ixion's orbit is slightly tilted, and it may belong to the same family of objects as Pluto, called the Plutinos, which are locked in a 2 to 3 resonance with Neptune. If Pluto is the best-known member of that resonance group, Ixion is the quiet cousin, who rarely gets invited to the spotlight but still keeps perfect time. There are many others, each with their own quiet quirks. There is Vada, about 700 kilometers wide, travelling with a small moon named Ilmara, both named after mythological creators. There is Huya, reddish and dark, looping around the sun on an eccentric orbit. There is Chaos, whose path lies just beyond Pluto, named with a hint of wry humour for a world that is in fact steady and well behaved. There is even a little object called Snow White, though it turned out not to be white at all but pale red, like so many of its distant neighbours. Each of these worlds is small, cold and silent, yet they form a sprawling, overlooked population at the edge of the sun's domain. What makes them even more mysterious is how many more there may be. Our best telescopes can only see objects down to a certain size and brightness, and only when they happen to be near their closest point to the sun. Beyond that, they fade into invisibility. Astronomers estimate that there could be hundreds, perhaps thousands, of dwarf planet-sized objects hidden in the Kuiper belt and beyond, waiting quietly in the dark. Some may be larger than Pluto, some may be smaller than Ceres, most are likely still undiscovered, their dim light lost in the background of the stars. This vast hidden population suggests something tantalizing. The solar system as we know it is incomplete. The tidy textbook diagram of 8 planets circling the sun is only the bright inner core of a much larger, fainter system. Beyond Neptune lies a kind of cosmic attic, crammed with forgotten relics from the solar system's birth. These icy worlds never grew large enough to become planets, but they never disappeared either. They stayed where they were cast, drifting like ancient embers in the cold. And then there is the whisper of something larger still. Some astronomers believe the strange orbits of these distant dwarfs hint at the pull of an unseen giant, a hypothetical Planet 9. This imagined world would be several times more massive than Earth and orbit hundreds of astronomical units from the Sun, far beyond even the reach of Pluto. Its gravity, if it exists, might be gently herding many of these small worlds into aligned orbits, like a hidden conductor guiding a distant choir. No one has seen Planet 9 yet, and it remains speculative, but its possible presence haunts the Kuiper belt like a rumour. The idea that an entire planet could still be hiding, unseen, in the solar system's outer shadows is both unsettling and oddly comforting. The truth is that our map of the solar system fades into uncertainty beyond Neptune. The outer darkness is too vast, too sparsely lit. We have charted only the brightest specks, the ones that happen to wander near enough for our telescopes to catch. Beyond them, the space grows blank again, waiting to be filled in. For now, Salacia, Varuna, Ixion and their quiet kin stand as the visible tips of an unseen iceberg of worlds. There is something humbling in that. We live in a system that feels familiar, yet most of its mass and most of its members remain invisible. The planets we know are the grand, glowing halls at the centre of the solar system, but around them stretches a dark, endless suburb of frozen wanderers, each carrying fragments of the solar system's earlier story. They are the leftover pages of creation, still drifting where they were first set adrift. Imagine them together, scattered across a sphere thousands of times wider than the space between Earth and the Sun, each one turning slowly, alone, yet part of a hidden family we're only just beginning to notice. It is a comforting thought that while our days are quick and noisy, out there are worlds that move with infinite patience. They do not shine brightly or call attention to themselves. They simply orbit century after century, waiting quietly in the dark for the moment someone happens to look their way. Perhaps the solar system is less like a neat clockwork and more like a sprawling, half-forgotten archive. We know the bright volumes on the front shelf, but most of the collection is still buried in the back, covered in cosmic dust. The small distant dwarfs are the forgotten footnotes, yet together they are numerous enough to rewrite the story. Beyond the familiar planets, beyond even the known dwarf worlds, there may be an entire hidden solar system still lying in wait, a silent archipelago of icy spheres, turning slowly in the dark, patiently keeping their place on the edge of the sun's light. Beyond the orbit of Neptune, the solar system does not simply end. It dissolves into a vast ring of small, icy bodies circling in slow silence. This is the Kuiper belt, a sprawling band of frozen debris left over from the birth of the planets. It begins just past Neptune at about 30 astronomical units from the Sun and stretches outward for at least 50 more. If the inner solar system is a bright, bustling city of worlds, the Kuiper belt is its quiet countryside, wide, cold and full of old things that have barely changed in billions of years. The Kuiper belt is named after Gerard Kuiper, a Dutch-American astronomer who proposed in the mid-20th century that a reservoir of small icy objects' bodies should exist beyond Neptune. He was not the first to suggest it, but his name became attached to the idea, and when the first objects beyond Pluto were discovered in the 1990s, the region became known as the Kuiper belt. Since then, thousands of objects have been found there, and astronomers now think there may be billions of them. Icy remnants from the solar system's youth, still quietly orbiting where they were left. In the early days of the solar system, about 4.5 billion years ago, a vast disk of gas and dust surrounded the newborn sun. Within this disk, tiny grains of ice and rock stuck together, forming clumps, then boulders, then planetesimals, objects big enough for gravity to pull them into spheres. Closer to the sun, where it was warm, only rock and metal could survive, and these materials built the inner planets. Farther out, where it was cold, ice was plentiful, Here the giant planets formed, sweeping up most of the available material, but not all of it. Many of the icy planetesimals were scattered outward by the gravity of Jupiter, Saturn, Uranus, and Neptune, flung into distant orbits like pebbles tossed from a slingshot. The Kuiper belt is the graveyard of those survivors, the leftovers of creation that never grew large enough to become planets. Most Kuiper belt objects are small, tens or hundreds of kilometers wide, and irregular in shape. They are made mostly of frozen water, methane, nitrogen and carbon-rich compounds, mixed with some rock. Many are dark, stained by tholins formed as cosmic rays slowly break down their surface ices over billions of years. A few, like Pluto, Eris, Haumea, and Makemake, are large enough to be spherical, but they are the exceptions, the giants of a population mostly made of fragments. If you could stand on one of these little worlds, the nearest neighbour might be millions of kilometres away, faint and cold, its light no brighter than a distant star. The distances between objects are immense. Even though the Kuiper belt is full of material, it is also vast, and the individual bodies are scattered across billions of cubic kilometres of space. It is not like the crowded asteroid belts seen in science fiction, where rocks tumble past one another in swarms. Out here, space itself dominates. The objects move like slow solitary travellers, their orbits taking centuries or millennia to complete. Collisions are rare, but when they do occur, they are slow and gentle by cosmic standards, more like two drifting icebergs nudging together than a fiery crash. Over eons, these quiet collisions grind surfaces smooth and scatter fresh material into space, a soft, ongoing erosion that reshapes the Kuiper belt grain by grain. The sunlight is weak here. At the distance of the Kuiper belt, it is hundreds of times dimmer than on Earth. It does not warm so much as faintly illuminate. The surfaces of these worlds remain frozen at temperatures near -200 degrees Celsius. Any atmosphere that might form would quickly collapse back onto the surface as frost. The cold preserves them almost perfectly, like ancient artifacts locked in ice. A crater blasted billions of years ago may still look fresh, its edges sharp, its dust undisturbed by wind or rain. Because the Kuiper belt is so pristine, it offers scientists a glimpse of what the early solar system was like. The objects here have changed little since they first formed. They are time capsules from a forgotten era, holding clues about the materials and conditions from which the planets emerged. Studying them is like reading the rough draft of the solar system before the planets rewrote it. Even their compositions, water ice, methane ice, dark organics, are the same ingredients that helped seed Earth with the materials for life. It is humbling to think that something as small and silent as a Kuiper belt object might have played a part in shaping oceans, atmospheres, and eventually living worlds. Pluto was the first known member of this distant family, discovered in 1930. For decades it was thought to be alone, a solitary outpost at the edge of the Sun's domain. Then, starting in the 1990s, one after another, new worlds were found beyond it. Quaoar, Varuna, Ixion, Haumea, Makemake, Eris, and many more. Each discovery revealed that Pluto was not an oddball, but part of an entire population, and that the solar system's edge is far more crowded than anyone had imagined. These finds reshaped our understanding of the solar system's structure, showing that the Kuiper belt is not a thin border, but a broad and ancient region, the Sun's own forgotten hinterland. There are different kinds of objects in the Kuiper belt. Some are called classical Kuiper belt objects. These follow nearly circular, stable orbits that have probably changed little since the solar system's formation. Others are resonant objects, whose orbits are locked in gravitational rhythms with Neptune. Pluto, for example, is in a 2-to-3 resonance, completing 2 orbits for every 3 of Neptune's. This delicate balancing act keeps it from ever colliding with Neptune even though their paths cross. There are also scattered disk objects, which have been flung into elongated, tilted orbits by past encounters with Neptune. These scattered objects blur the outer edge of the Kuiper belt, bridging the way to the even more distant Oort cloud. Altogether, These icy bodies form what is essentially a cosmic gravel path, the leftovers of planet building that never got swept up. They are not failed planets. They are the raw material that was left behind when the great worlds grew and cleared their orbits. In that sense, the Kuiper belt is less a graveyard than a museum, still holding the ancient ingredients of planetary construction. If you could look down on it from above, it would appear as a broad, thin ring dusted with millions of tiny motes, each one moving at its own unhurried pace. And beyond the Kuiper belt, the darkness only deepens. The scattered disk stretches even farther, and beyond that may lie the Oort cloud, a vast spherical halo of icy bodies that marks the outermost boundary of the sun's gravitational reach. The Kuiper belt is just the inner edge of this larger unseen structure, a faint veil between the known solar system and the deep interstellar dark. There is a quiet kind of beauty in its existence. The Kuiper belt is not dramatic. It does not blaze or roar or crash. It simply drifts, patient and cold, like the lingering breath of the solar system's creation. Each tiny world is a fragment of history, still circling after billions of years, still keeping its place in the great slow waltz around the sun, while the inner planets blaze with activity and the giant planets whirl with storms. The Kuiper belt waits in silence, a forgotten border of ice and shadow, carrying the memory of how everything began. Beyond the soft, orderly ring of the Kuiper belt lies a place where neatness ends. Here, the solar system grows restless, and the orbits of its icy wanderers twist into wild, tilted loops. This is the scattered disk, a vast, ragged region where the sun's gravity still whispers, but no longer holds a firm grip. The objects here are flung far and wide on elongated, chaotic paths, looping out into the deep dark before falling slowly back again. They are the castaways of the early solar system, forever wandering, forever returning, like exiles bound by invisible threads. Unlike the Kuiper belt, which lies mostly in a flat, gently curved plane, the scattered disk is untidy. Its members swoop at sharp angles, diving steeply above and below the ecliptic like startled birds. Some tilt as much as 40 degrees from the solar system's main plane. Their orbits are long ellipses, stretched thin and pulled into space like strands of glass. While Kuiper belt objects tend to stay clustered between about 30 and 50 astronomical units from the sun, scattered disk objects can travel hundreds of astronomical units away before swinging back inward. Their paths are slow, solitary arcs through an expanse so empty that they might go centuries without seeing another world. Eris, the world that famously helped dethrone Pluto, is one of the best-known scattered disk objects. It spends most of its 557-year orbit far beyond the Kuiper belt, looping out to almost 100 astronomical units before drifting back to around 37. At its farthest, the sun would appear no brighter than a fierce star, and the light would take nearly 9 hours to arrive. Eris is not alone. Dozens of other scattered disk objects have been found. Icy bodies like 2004 XR190, nicknamed Buffy for its oddly high inclination, or 2007 TG422, which follows a staggering 1,400-year orbit. Each one is an eccentric traveller, carving its own lonely path through the dark. How they came to be scattered is a story from the solar system's unruly youth. Billions of years ago, as the giant planets were forming, they did not stay where they began. Jupiter and Saturn drifted inward and outward like great shifting anchors, while Neptune likely migrated outward, ploughing through the disk of icy planetesimals like a slow snowplough. As it moved, Neptune's gravity flung countless small worlds outward in slingshot arcs, scattering them into elongated orbits. Some were hurled entirely out of the solar system, cast into interstellar space. Others settled into distant looping orbits that still bring them back around the sun, though on paths so stretched and tilted they barely seem part of the same system anymore. These survivors became the scattered disk. There may have been other influences as well. Some astronomers suspect that in the sun's early days, when it was still part of a dense star cluster, Passing stars may have brushed close enough to tug at the young solar system's outer edges. A single flyby from a neighbouring star could have yanked small, icy worlds outward into wider, more tilted orbits, planting the seeds of the scattered disk. Others imagine a long-lost rogue planet, perhaps an ice giant ejected from the inner solar system, briefly wandering through the outer regions and leaving chaos in its wake before vanishing into the void. Whether the culprit was Neptune, a stray star, or a forgotten planet, the result was the same, a population of objects flung outward, like sparks frozen in midair. The scattered disk is not crowded. In fact, it is almost hauntingly empty. Each object is separated from its neighbours by billions of kilometres of silence. They are like lonely ice boulders drifting through blackness, each one tumbling slowly as it arcs through its vast ellipse. Sunlight out here is barely more than a glow, hundreds of times dimmer than on Earth. It does not warm, only faintly glints off patches of frozen methane or water ice, then fades again into darkness. The surfaces of scattered disk objects remain locked in deep cold, their ancient craters sharp and undisturbed, their dust unmoved by any breeze. There is a quiet beauty in their chaos. Imagine standing on one of these far-flung worlds. The sun would be a hard white spark lost among a sea of stars. The nearest other object might lie billions of kilometres away, invisible to the eye. The sky would be a silent ocean of starlight, and the horizon would stretch black and endless. Every step would feel weightless, slow, as though even time has grown too thin to support haste. Out here, motion itself becomes delicate. The scattered disk is also a place of extremes in time. While Pluto takes just under 2.5 centuries to complete an orbit, some scattered disk objects take thousands of years. Their journeys carry them so far from the sun that they spend centuries frozen in near stillness before falling inward again like patient comets. To watch their progress is to see motion slowed to almost nothing, the solar system breathing in eons instead of years. These objects may also form the gateway to something even farther, the Oort cloud, the vast spherical shell of icy bodies that is thought to surround the solar system. Many long-period comets that swoop into the inner solar system may begin as scattered disk objects, nudged outward over time until they become part of the Oort cloud, only to be jostled back inward by passing stars millions of years later. In this way, the scattered disk is like a halfway house between the known solar system and interstellar space, a twilight region where our sun's gravity begins to loosen and the galaxy begins to take over. Finding scattered disk objects is difficult. They are small, dark and slow, barely moving even over years of observation. Many are likely still undiscovered, invisible specks gliding in the black. What we see are only the brightest and nearest, the ones that happen to wander close enough for our telescopes to notice. Each new discovery redraws the solar system's edge, pushing the known boundary farther outward like ripples on a pond. Yet for all their distance and disorder, scattered disk objects are not random. They are survivors of an ancient upheaval, fossils of chaos preserved in ice. Their tilted orbits record the solar system's forgotten turbulence, the gravitational brawls that once reshaped everything. They are reminders that the neat, clockwork order of the planets is only the final layer, the polished surface of something that was once wild and unruly. In their lonely arcs, there is a strange sense of balance. Each scattered object may move on a path unlike any other, yet together they form a diffuse halo, circling the sun in slow counterpoint to the planets. They are the outer echoes of the solar system's birth, still wandering where they were thrown, still loyal to the sun, even from the edge of its reach. While the planets spin and the inner worlds blaze with life and storms, the scattered disk waits in silence, its wild orbits gliding endlessly through the dark. It is easy to forget that they are part of the same system as Earth. They move so far away, so quietly, that they seem almost detached, and yet they are bound, however faintly, by the same sunlight that warms our oceans and grows our forests. The scattered disk is a reminder of how far that warmth stretches, how thin and faint and persistent the sun's pull really is. Even here, where order phrase and orbits grow wild, the solar system still holds its scattered children close, letting them roam but never letting them go. Far beyond the scattered edge of the solar system, past the Kuiper belt and the wild orbits of the scattered disk, lies a realm so distant and so quiet that no human instrument has ever seen it directly. It is called the Oort cloud, and if it exists as scientists believe, it is the solar system's outermost veil, a vast spherical shell of icy bodies surrounding everything we know. It is not a ring or a belt, but a bubble, a frozen halo that stretches so far that the sun itself becomes just another bright star in the sky. The Oort cloud is still theoretical. No spacecraft has ever visited it, and no telescope has ever imaged its countless supposed members. Its existence is inferred from the long-period comets that sometimes appear in the inner solar system, flaring like ghostly arrows from the black. These comets arrive on orbits so long and stretched that they cannot have come from the Kuiper belt or the scattered disk. Some take millions of years to complete a single circuit around the sun, their paths arcing far beyond the known planets. The simplest explanation is that they come from a distant reservoir of icy bodies, the Oort cloud, sent inward occasionally by the subtle nudges of passing stars or the gravity of the Milky Way itself. If the Oort cloud is real, it is enormous. It may begin around 2,000 astronomical units from the Sun and extend to as far as 100,000. To put that in perspective, Earth orbits at 1 astronomical unit. Pluto orbits at 30. The Oort cloud could be more than 3,000 times farther than Pluto. At its outer edge, the Sun's gravity is so faint that it barely holds on. Beyond that point, interstellar space begins, and the influence of other stars becomes stronger than our own. The Oort cloud is the solar system's fading breath, where our star's domain ends and the galaxy begins. Within that frozen halo could be trillions of small icy worlds, each no more than a few kilometers across, and perhaps billions more the size of mountains. They are thought to be made of water ice, methane ice, ammonia ice, and other frozen volatiles mixed with rock and dust, the leftover building blocks of planets from the solar system's chaotic youth. Long ago, when the giant planets were forming, they flung vast numbers of icy planetesimals outward like pebbles flicked from a sling. Most were lost to interstellar space, but some were caught in the sun's gravity just enough to remain bound, settling into a distant spherical cloud. Over time, passing stars and the tidal pull of the Milky Way gently stirred them into a vast diffuse shell, where they have floated ever since, almost untouched. If you could somehow stand on one of these frozen bodies, and it would be more like perching on a drifting iceberg than standing on a planet, the sun would be just another star in the sky, bright but small, not much larger than the other pinpoints scattered around it. The nearest neighbouring world might be millions or even billions of kilometres away. The sky would be black and silent, the stars sharp and steady. The surface underfoot would be ancient ice, untouched for billions of years, its craters crisp and unweathered, its dust unmoved by wind or time. Time itself would feel different here. Orbits in the outer Oort cloud could take tens of millions of years to complete. Entire species could evolve and vanish on Earth before one of these silent objects makes a single trip around the Sun. Even the inner Oort cloud, if it exists, would hold objects with orbital periods measured in millions of years. Compared to this, the familiar planets are in a frantic whirl, spinning around the Sun like bees. The Oort cloud moves at the pace of continents drifting, of mountains rising, slow, patient and eternal. Every so often something disturbs this quiet. A passing star drifting close to our solar system might tug at the fragile orbits of a few Oort cloud bodies, loosening their grip on the Sun. The galactic tide, the faint gravitational pull of the Milky Way's disk, may do the same. These tiny nudges can send an object drifting inward, falling for millions of years until it finally enters the inner solar system as a long-period comet. When it nears the Sun, the heat releases gas and dust in a glowing tail, turning a faint invisible speck into a bright temporary spectacle. After a brief blaze through the planets, it slips back outward, fading into the dark for another immense circuit. These comets are our only messengers from the Oort cloud. They carry ancient material from the dawn of the solar system, unchanged for billions of years. Their dust contains water, carbon compounds, and organic molecules, the same ingredients that may have helped seed life on Earth. Every time a comet appears in the night sky, it is a visitor from this hidden halo, a fragment of the solar system's forgotten edge paying a fleeting call. The Oort cloud may be the solar system's largest structure, yet it is also its most elusive. Because its members are so distant and so small, they reflect almost no light, and even our best telescopes cannot see them directly. Their orbits are too vast to track, their motions too slow. We know they are likely there not by sight but by pattern, the way deep ocean currents are known by the drift of floating debris. The long looping comet orbits point back toward a vast unseen reservoir, like arrows leading away from a hidden shore. There is something hauntingly beautiful about imagining this place. The known planets, the Kuiper belt, the scattered disk, all of them are just the bright inner rooms of the solar system. The Oort cloud would be its silent cathedral, dark and hollow, stretching for light years in every direction. It is not bustling or violent. It does not shine. It simply floats, vast and cold and slow, a frozen halo suspended between the pull of our sun and the pull of the galaxy beyond. It may also be shared. Some scientists suspect that the Oort cloud's outermost edge overlaps with the comet clouds of other stars. Over the billions of years since the Sun was born in a crowded star cluster, passing stars may have stolen some of our icy bodies and left some of their own behind. The Oort cloud could be a mingled borderland between stars, a place where worlds from different suns drift together without knowing which home they came from. In that sense, it is not just the edge of our solar system, it is the beginning of the space between. We may never see it directly, no spacecraft is even close. The most distant probe humanity has ever launched, Voyager 1, is more than 160 astronomical units from the Sun, and it has not yet reached the inner edge of where the Oort cloud is thought to begin. It may be tens of thousands of years before it crosses that dark threshold. Even then, it will pass silently through without knowing, gliding between scattered icy grains so far apart they may never notice each other's existence. And yet, the Oort cloud matters. It is a reminder that our solar system is not a tidy set of planets on a flat table. It is a vast, layered structure, with a bright hearth at its centre and a cold, unseen halo at its edge. It shows that our sun's influence reaches unimaginably far, holding its forgotten children loosely, even at the threshold of the stars. The Oort cloud is the solar system's softest whisper, its faintest breath. It is where our star's gravity fades into the galaxy's pull, where the boundary between home and everything else begins to blur. It may be dark and distant and silent, but it is part of us. It is the final, frozen memory of how our solar system began, and the place where, someday, its last wandering fragments will quietly wait out the ages, circling a sun they can barely see. Long before the solar system became the familiar family of planets we know today, it was something much less organised. A vast, swirling disk of dust, ice and gas wrapped around a newborn sun. There were no planets, no moons, no comets, just a haze of microscopic grains drifting through warm light. Yet hidden in that haze was everything. Every mountain, every ocean, every moonlit landscape waiting to exist was suspended there, like powder waiting to settle. It was in this quiet chaos that the forgotten worlds were born. The process began small, almost impossibly so. Tiny specks of dust collided and stuck together through static forces, building up into fluff-like clumps. It sounds fragile, and it was. Most collisions broke the clumps apart again, but the solar system was generous with time. Over millions of years, the survivors grew larger, their gravity becoming just strong enough to attract other grains. As they gathered more material, they became pebbles, then boulders, then mountain-sized objects called planetesimals. These planetesimals were the building blocks of everything that followed, the raw seeds of planets. The early solar system was crowded with them. Countless planetesimals whirled around the sun on overlapping paths, bumping and merging like slow-motion billiard balls. When two collided gently enough, they fused, creating a single larger body. When they hit too fast, they shattered, scattering debris that other planetesimals would later sweep up. It was a cosmic construction site, and also a demolition derby. Every world you know today was sculpted from this chaos, pieced together by an endless sequence of collisions. Some planetesimals grew quickly, especially in the inner regions of the disk where there was less space and more material packed tightly together. As these growing worlds reached sizes of hundreds or thousands of kilometers, their gravity strengthened enough to pull themselves into spheres. They began to heat from within as radioactive elements decayed and as the energy from impacts built up, melting their interiors and allowing heavy materials like metal to sink, while lighter materials floated upward. This process turned them from loose rubble piles into layered, differentiated worlds. The biggest of them cleared their orbits of smaller neighbours and became full-fledged planets. But farther from the sun, where the disk was thinner and colder, growth was slower. There was more room to drift and fewer collisions to drive rapid accretion. Here, many planetesimals never gathered enough material to become planets. They stayed small, orbiting as quiet leftovers while the larger worlds grew and migrated. Some were jostled inward and became moons. Others were thrown outward by the gravity of the giants, flung into the scattered disk and the Oort cloud. Still others simply stayed where they were, drifting in the outer darkness, their growth arrested, their ambitions cut short. These are the forgotten worlds, the dwarf planets and icy remnants that never joined the solar system's main stage. Their small size does not mean they were failures. In a sense, they are fossils, snapshots of what the early stages of planet building look like. While the planets went on to churn with volcanoes and oceans and tectonic reshaping, the dwarf worlds stayed mostly as they were, frozen, silent, and unchanged. Their surfaces still bear the craters from the ancient era of heavy bombardment, and their interiors remain as they formed billions of years ago. Looking at them is like looking at the solar system's childhood pressed into ice. There were many near misses along the way. Some planetesimals grew large enough to be almost planets, only to be stunted by a poorly timed collision that shattered them back into rubble. Others might have become planets if they had formed just a little closer to the sun, where material was denser and growth was faster. A few may have been well on their way to greatness before being flung out by the migrating giants, exiled into the cold where growth became impossible. The solar system is full of these cosmic what-ifs, worlds that almost were, stories that almost happened. The dwarf planets we see today are simply the ones that survived those close calls intact. The difference between a planet and a dwarf planet is subtle but profound. It is not just about size. Pluto, for example, is smaller than Earth's moon, yet complex and active. The key distinction is that planets cleared their orbits of other debris, sweeping up or ejecting their neighbours through their gravity. Dwarf planets never reached that tipping point of dominance. They remained part of a crowd, sharing their paths with countless other objects. In that sense, they are like actors who showed up to audition, but were never cast in leading roles, yet still linger in the background of the story, quietly holding the same ancient lines they always had. Even their shapes tell a story of balance. A world becomes round only when it grows large enough for its own gravity to pull it into a sphere, overcoming the strength of its rocky or icy material. This threshold, called hydrostatic equilibrium, marks the line between the small lumpy bodies and the rounded dwarf planets. Ceres reached it, Haumea, Makemake and Eris did too, but most of their neighbours never did. They remain irregular, like frozen fragments of broken pottery drifting on the edges of sunlight. The giants, meanwhile, took a different path. In the outer solar system where ices were plentiful, some planetesimals grew fast enough to become cores of gas giants before the young sun's solar wind blew away the leftover gas. These cores pulled in vast envelopes of hydrogen and helium, ballooning into Jupiter and Saturn. Others became ice giants like Uranus and Neptune. Once the gas was gone, no other planetesimals could grow that way. The window had closed. The giants rose quickly while the dwarfs lingered in quiet obscurity. Yet the line between success and obscurity was razor thin. If timing or position had shifted slightly, the solar system might have looked entirely different. Pluto could have become a small planet while Mars remained a dwarf. Ceres could have merged with other planetesimals to form a planet between Mars and Jupiter, instead of being stranded as the largest body in the asteroid belt. Haumea might never have been shattered into its strange spinning shape, and Sedna might have stayed close instead of being cast into a vast 11,000-year orbit. The worlds we see now are only the survivors of countless near misses and blind chances. There is something humbling in that. The solar system we know is not inevitable. It is a patchwork of victories and accidents, of giants that grew too quickly, and small worlds that simply never stopped being small. The forgotten worlds are not mistakes. They are the quiet echoes of everything that might have been. Each one is a frozen alternate history, carrying the story of a path not taken. Even now, the process of planetesimal formation continues in faraway star systems. Telescopes have captured disks of dust around young stars, glowing softly as new worlds slowly take shape within them. Some of those worlds will become planets, most will not. Many will stay small and quiet like the dwarfs in our own outer solar system, drifting forever in the outskirts, unnoticed yet enduring. This is not a flaw. It is how planetary systems are built, not as perfect arrangements, but as sprawling families of successes and remnants, of worlds that flourished and worlds that froze. The forgotten worlds remind us that being small does not mean being unimportant. They are pieces of the solar system's foundation, the bricks that never became towers but still hold up the structure from below. Without them, the planets could never have formed. Without their fragments, Earth might never have received its water, its carbon, or the sparks of chemistry that gave rise to life. The giants may command attention, but the dwarfs are the quiet architects of everything that followed. They are not broken worlds. They are simply unfinished, stories that paused at the first chapter and stayed there, still turning, still waiting, long after the rest of the solar system raced ahead. And in their frozen silence they hold something precious, the memory of how it all began. For most of human history, the word planet was a simple thing. To ancient skywatchers, planets were the wandering stars, points of light that drifted across the fixed constellations over weeks and months. Mercury, Venus, Mars, Jupiter and Saturn were known long before telescopes existed, their slow dances mapped by patient eyes. Then came the telescope, and with it the discovery of Uranus in the late 1700s, Neptune in the 1800s, and Pluto in 1930. The solar system's roster seemed to grow with each new revelation. For decades, schoolbooks cheerfully listed 9 planets, their names memorized like a spell. But as our eyes sharpened and our reach extended, the solar system grew crowded. New discoveries blurred the boundaries between planet, moon, asteroid and something in between. By the early 2000s, astronomers faced an uncomfortable truth. The word planet had never been clearly defined. It had been more of a tradition than a rule, and tradition began to crack when Pluto's throne was quietly challenged by new arrivals from the deep. The turning point came in 2005 when astronomers discovered Eris, a distant icy world slightly smaller than Pluto but more massive. If Pluto was a planet, then surely Eris must be as well. But if Eris was a planet, what about the dozens of other similar-sized bodies now being found beyond Neptune? Should the list of planets expand to 10, 12, or 50? The once tidy solar system threatened to become a catalogue of icy pebbles, and something had to give. In 2006, the International Astronomical Union, or IAU, gathered in Prague to decide what the word planet truly meant. After heated debates, they voted on an official definition. According to the IAU, for something to be a planet, it must meet 3 criteria. First, it must orbit the Sun. Second, it must be massive enough for its own gravity to pull it into a nearly round shape, a state known as hydrostatic equilibrium. And third, it must have cleared its orbit of other debris, meaning it dominates its orbital zone, sweeping up or ejecting other objects that cross its path. Pluto met the first 2 criteria but failed the third. It shares its orbit with countless other icy bodies in the Kuiper belt and does not gravitationally dominate its region. So, Pluto was reclassified as a dwarf planet, along with Eris, Ceres, Haumea and Makemake. The number of official planets dropped from 9 to 8. In classrooms around the world, posters were updated, mnemonics rewritten, and generations of students mourned the small, lonely world at the edge that had suddenly been told it was no longer one of the big kids. The decision sparked an uproar far beyond the astronomy community. Many people had grown up with Pluto as a beloved part of the planetary family. Its demotion felt personal, like someone had quietly removed a childhood friend from the family photo. Some scientists protested too, arguing that the clearing the orbit requirement was vague and biased against small outer worlds. After all, Earth still shares its orbit with thousands of asteroids. By that standard, they said, even our planet might fail the test. Others countered that without such a rule, the word planet would balloon until it lost all meaning, covering hundreds or even thousands of objects. Beneath the emotions lay a deeper question. Is a planet defined by what it is, or by where it lives? The IAU's definition tied planethood to location and behaviour, not just size or shape. This meant that 2 objects of identical size and composition could be classified differently depending on their neighbourhoods. Pluto would be a planet if it orbited alone near Earth's distance, but out in the crowded Kuiper belt it is only a dwarf. This approach keeps the list of planets neat, but it feels oddly arbitrary, as though Pluto was punished for living in the wrong part of town. The debate did not end in 2006. In the years since, many astronomers have called for revisiting the definition. Some propose a simpler rule. If an object is large enough to be round, it should be called a planet, regardless of where it orbits. This would instantly restore Pluto and dozens of other dwarf worlds to full planetary status, expanding the family tree dramatically. Others have suggested new categories such as planetary mass objects, or worlds, that would encompass both planets and dwarfs, sidestepping the argument entirely. There are also disagreements about the IAU's focus on orbiting the Sun. Moons like Ganymede and Titan are larger than Mercury, and more geologically active than many planets, yet they are not called planets simply because they orbit other planets instead of the Sun. Some scientists argue that they should be considered satellite planets, while others prefer to reserve the word planet for things that orbit stars. Even exoplanets, planets around other stars, were not part of the IAU's original definition, though they are now widely included by common sense if not formal wording. All of this reveals a curious truth. The word planet is not a scientific law but a human label. Nature does not draw lines between planets and non-planets. It simply builds worlds of all sizes, shapes and orbits. The categories we use are tools to make sense of the chaos, and those tools change as our understanding grows. Once the Sun and Moon were counted as planets. Once Ceres and Vesta were planets before being demoted to asteroids. Now Pluto has joined them in the category of dwarf planet, and one day, new discoveries may shuffle the list again. Even now, the solar system resists neat classification. Objects blur categories. Some asteroids show signs of past volcanism. Some comets seem more like dormant rocky worlds wrapped in ice. dwarf planets straddle the line between minor body and major world, and moons blur it further by being fully planet-like yet tethered to larger companions. The more closely we look, the less the solar system resembles a set of tidy boxes, and the more it resembles a continuum, a spectrum of worlds, large and small, round and irregular, quiet and active, each shaped by the particular story of its birth and orbit. Pluto's demotion was never really about Pluto. It was about the flood of new worlds discovered beyond it: Eris, Haumea, Makemake, Sedna, and countless smaller bodies. It was about the realization that the solar system is not 9 planets, and then emptiness, but a sprawling archipelago of icy spheres. The definition changed not to erase Pluto, but to make room for everything else. Yet in doing so, it revealed how fragile our labels are, and how easily they crack when confronted with the universe's stubborn refusal to fit inside them. There is something quietly beautiful about that. Our words are temporary scaffolding. The worlds themselves endure. Pluto still circles the sun, icy and bright. Whether we call it a planet or a dwarf, Eris gleams far beyond, unmoved by human arguments. The cosmos does not care how we categorize it. It simply is. The debate about planethood is really a reflection of us, of how we struggle to define things cleanly in a universe that is gloriously untidy, and perhaps that is fitting. The concept of planet has always evolved as our vision has widened. It will likely change again as new worlds are found, new moons are explored, and new star systems are mapped. One day, our descendants may laugh at our 8-planet model, seeing it as quaint and incomplete. They may call hundreds of objects planets, or none at all. They may discard the word entirely and speak instead of worlds, each unique, each wondrous, each part of the same cosmic family. In the end, whether Pluto is called a planet or not matters less than the fact that it exists, spinning in sunlight at the edge of our reach. The same is true of every dwarf and every giant, every wandering ice ball and every blazing world. Names shift like sand, but the worlds remain. The science of classifying planets is not about drawing a final border. It is about learning how wide and strange and beautiful our solar system really is, and about remembering that its wonder does not depend on the labels we give it. For now, most of the forgotten worlds drift unseen, known only as faint specks of moving light in distant telescopes. Their surfaces are maps we've never read, their craters and ridges still hidden behind the black. But one day, we may go to them. The urge to explore has always pulled humanity outward, past the horizon and into the unknown, and the outer solar system is the last great shore still waiting. The future of exploration may carry us to these quiet worlds, gliding slowly past them as they turn in the pale glow of the sun, revealing their secrets one frozen frame at a time. We have already taken the first steps. In 2015, NASA's New Horizons spacecraft swept past Pluto after a journey of nearly a decade, transforming it from a distant dot into a world. For the first time, we saw its heart-shaped plains of nitrogen ice, its jagged mountains of frozen water, and its thin, hazy atmosphere stretching into space. Pluto was no longer a symbol or a controversy. It was real, alive with weather and history, layered with geology and time. That flyby changed how we see the outer solar system. What had seemed like empty black suddenly looked like a gallery of waiting worlds. New Horizons did not stop there. After Pluto, it continued onward into the Kuiper belt and visited Arrokoth, a small contact binary object shaped like a gently flattened snowman. It is only about 30 kilometers long, yet it revealed an untouched landscape from the solar system's earliest days. Its surface is smooth, lightly cratered, and painted a soft red by ancient tholins. Arrokoth showed what the first building blocks of planets might have looked like before they were melted and remade. It was a glimpse straight into the past, a relic that had drifted unaltered for over 4 billion years until our tiny machine passed by to say hello. That success sparked new dreams. Scientists have drawn up ideas for missions to other forgotten worlds, each one a leap into the deep cold. Ceres, though much closer than the outer dwarfs, has already been visited by the Dawn spacecraft, which orbited it from 2015 to 2018. Dawn found bright salt deposits from ancient briny water, mysterious cryovolcanoes that once oozed slushy ice, and signs that liquid water may still linger deep underground. But there is still so much left unknown. How thick that hidden layer might be, whether any chemistry is stirring inside it, and how such a small world stayed geologically alive for so long. Future probes could return to Ceres with drills or landers, searching for the traces of life-friendly environments hidden under its frozen crust. Beyond the asteroid belt, missions would become more daring. There are concept studies for Flybees of Haumea, with its strange stretched shape and faint ring, and for orbiters that could study Eris up close, measuring its mass and probing its nitrogen ice surface. These journeys would take decades. Eris, for example, lies more than 14 billion kilometers from the Sun at its farthest. A spacecraft travelling at New Horizons speed would still need over 20 years to reach it. Yet the wait does not dim the dream. Space exploration is patient by nature, and the outer worlds are patient too. They have been waiting for billions of years. A few more decades is nothing to them. Some engineers imagine sending swarms of tiny probes instead of single large craft. These could be carried by solar sails, using sunlight to push them outward like drifting seeds. Others envision nuclear-powered ion engines that would glide silently for decades, sipping fuel while accelerating to record speeds. There are even proposals for using the Sun's gravity to slingshot probes faster than anything built before, diving close to the Sun to gain momentum before flinging themselves outward toward the frozen edge. The technology does not exist yet, but neither did New Horizons when Pluto was first discovered. The path from dream to reality is always longer than it looks, and yet it is always walked. Exploration would not only be about science, it would also be about perspective. To see these worlds up close would be to see time made solid. Their surfaces are archives of the early solar system, unedited and unweathered, keeping their craters and ridges like pressed flowers from a forgotten age. A camera drifting past Haumea could capture the glint of its icy crust, spinning like a cosmic jewel. A probe flying by Sedna might photograph the faint red glow of its tholin-stained surface against the black, the Sun just a white star far behind it. Even if they remained silent and airless, these worlds would speak volumes through their stillness. Every step outward would also sharpen our sense of home. When New Horizons looked back at Pluto, it saw a blue haze of atmosphere glowing against the void, and beyond it, a faint spark of the Sun. That spark is what warms every sea and stirs every wind on Earth. To see it from the outer darkness is to understand how rare and fragile it is. The forgotten worlds are not places where life thrives, but they remind us of the improbable conditions that let it thrive here. Each icy flyby would be a kind of mirror, showing how much had to go right for Earth to become what it is. Eventually, if technology and patience align, we may even send landers. The idea of a small robot touching down on the reddish plains of Makemake, or the dark crust of Orcus, is still firmly in the realm of imagination, but so once was the idea of landing on Mars. These landers could carry drills to sample subsurface ice, spectrometers to sniff for ancient organics, and seismometers to listen for faint quakes inside the frozen ground. They might sit quietly for years, their solar panels dim in the weak sunlight, beaming whispers of data back across billions of kilometers. They would be like tiny emissaries left on forgotten shores keeping lonely watch. The journey would be slow. Signals would take hours to cross the void. Commands sent from Earth would arrive long after the moment had passed. The spacecraft would have to fly themselves, choosing when to turn, when to photograph, when to sleep. Each world would be revealed not in a flash, but in a long, graceful unfolding, frame by frame as the probe drifts closer, like watching a distant island emerge from the mist. There would be no quick triumph, only the quiet satisfaction of persistence, the slow unfurling of the unknown. There is something fitting about that pace. The forgotten worlds have been circling the sun for billions of years, changing only by the faintest increments. They are not in a hurry, and so our approach to them cannot be either. We will meet them on their timescale, drifting as they drift, patient as they are patient. It will be less like conquest and more like greeting old silent neighbours who have been here since the beginning. And when that day comes, when the first close-up images of Eris or Haumea or Sedna reach Earth, they may change how we think about the solar system entirely. They will show us not emptiness but abundance, not dead space but ancient stillness. They will remind us that the solar system is not just the bright inner worlds, but also the faint outer embers, the small and silent ones who kept their places while everything else rushed on. The future of exploration is not only about going farther, it is about going slower, listening longer, and noticing what has always been there. It is about drifting through the dark with curiosity as our compass, letting these forgotten worlds finally be seen. They have waited for eons, and when we finally arrive, they will still be there, turning softly under the pale glow of the sun, waiting to tell their stories to anyone patient enough to come close. In the grand family portrait of the solar system, the forgotten worlds barely show. They are small, distant, and silent, orbiting far from the warm glow of the sun. They do not command attention like Jupiter with its roaring storms or Saturn with its shimmering rings. They do not glimmer blue like Earth or glow red like Mars. At first glance they seem like footnotes, leftovers, drifting debris, fragments that never became anything more. And yet, they are among the most important worlds of all. They are the keepers of the solar system's memory, holding within their frozen crusts the story of how everything began. These worlds are ancient beyond comprehension. While the planets have churned and reshaped themselves with volcanoes and earthquakes, the forgotten worlds have remained largely unchanged for billions of years. Their surfaces are records of the early solar system, still etched with the scars of its chaotic birth. Every crater is a signature from the era of heavy bombardment, when the sky was full of falling stone and ice. Every grain of dust on their surfaces may be older than the continents on Earth. They are the closest thing we have to time capsules from that lost age, sealed in cold and darkness since before life began. By studying them, scientists can glimpse the raw ingredients that built the planets. The forgotten worlds are made of the same materials: water ice, methane, ammonia, carbon compounds and silicate rock that swirled together in the protoplanetary disk around the newborn sun. But while the planets used up or transformed most of their supply, the dwarfs and planetesimals never did. They stayed small, conserving their ancient chemistry. Sampling them would be like tasting the solar system's primordial soup, still chilled and preserved on the edge of space. They may even have shaped Earth itself. Many scientists think the water in our oceans was delivered by icy planetesimals from the outer solar system. Early Earth was too hot to hold water at first, and most of its original supply may have boiled away into space. Later, waves of small icy bodies crashed down, releasing water vapour that condensed into rain. Those same impacts may have delivered organic molecules, the carbon-rich compounds that seeded the planet with the building blocks of life. Without the forgotten worlds, Earth might have remained a dry rock under a silent sky. If that is true, then the oceans, clouds, and even our breath are gift from these quiet wanderers. Even now their chemistry may echo what once sparked life. Some contain complex organics called tholins, formed when sunlight and cosmic rays break apart simple ices and let the fragments recombine into long carbon chains. These tholins are reddish-brown, and they coat the surfaces of many distant dwarfs like ancient varnish. On Earth, similar organic molecules were likely present in the primordial seas where life first flickered awake. To find them frozen on worlds billions of kilometers away is to glimpse our own beginnings, reflected back at us from the dark. Their orbits tell stories too. The way these worlds move reveals how the planets once migrated, how Neptune may have swept outward like a slow tide, scattering small bodies as it went. Some were flung into the scattered disk, some cast into the Oort cloud, some trapped in resonances like Pluto and Orcus, forever dancing to Neptune's rhythm. The patterns of their paths are like fossilized ripples in space, recording the migrations of the giants. By tracing those ripples, scientists can reconstruct the solar system's hidden history, the part that happened long before Earth cooled enough to grow its first crust. And their silence has its own meaning. The forgotten worlds remind us that not everything must be large or loud to matter. They do not blaze with activity. They do not roar with storms or dazzle with rings. They simply are, holding their places faithfully on the edge of the sun's light. In doing so, they show that the solar system is not just the planets we know, but a whole architecture of small things, each piece shaping the whole in subtle ways. Even their gravity, though slight, shapes the paths of comets and dust, influencing the flow of material across the outer solar system. They also give perspective. Earth can feel like the centre of everything, warm and crowded with life. But from the distant edge, it is just another pale point glimmering near the sun. Seeing the forgotten worlds, still and unchanging, can be oddly comforting. They remind us that not all of existence is fast and fleeting. Some things endure almost without motion, keeping their slow watch as ages pass. Their stillness throws our quickness into relief, like the calm backdrop that makes a spark look bright. And in their quiet way, they are beautiful. Pluto with its soft nitrogen plains, Haumea spinning like a glittering oval, Makemake glowing red under starlight, Sedna wandering on its 11,000-year circuit. Each is a frozen work of art carved by time and left on display in the deep. Their beauty is subtle, hidden by distance, and perhaps that makes it more precious. They do not flaunt themselves. You have to look carefully, patiently, to even notice they are there. That is their greatest gift. They teach us to find wonder in what is overlooked. It is easy to marvel at Saturn's rings or Jupiter's storms. It is harder to feel awe at a dim speck of light moving slowly against the stars. But that dim speck may be older than any mountain, carrying more history than any library, and holding secrets that could rewrite our understanding of how planets form, how life begins, and how solar systems grow. The forgotten worlds ask us to slow down, to pay attention, to see the extraordinary hiding in the quiet. They also whisper something gently humbling. The solar system is not arranged for our understanding. It is not tidy. It is a sprawling family of worlds, some loud, some silent, some blazing, some barely visible. The giants at the centre and the dwarfs at the edge are made of the same stardust, shaped by the same forces, spun from the same ancient disk. To value only the large is to miss most of what exists. To value only the bright is to miss most of what endures. Even if no human ever stands on Sedna's frozen crust, or watches the sun rise over Orcus's dark horizon, their existence enriches the story we live in. They show that creation is generous, making far more worlds than it strictly needed, and leaving them to wander in quiet arcs for billions of years. They are not forgotten to the cosmos. They are simply patient, content to wait until someone finally notices them, and perhaps that is the heart of their meaning. The forgotten worlds show that wonder is not about scale or spectacle. It is about noticing, the same way a single seashell can hold the whole ocean in its spiral if you look closely enough. The giants may roar, but the small ones endure. They are the punctuation in the solar system sentence, the soft pauses that give shape to the story. Without them, the tale would be flatter, shorter, less rich. They are proof that even the smallest, quietest worlds can shape the grand design. They carried water to our seas, carbon to our soils, and history to our understanding. They helped make planets, and in doing so, they helped make everything that followed. They may be faint and far, but they matter deeply. They are the roots beneath the bright garden, the deep chords beneath the melody, the steady beat beneath the song of the sun. The forgotten worlds are not there to impress. They are there to remind that even in the coldest, dimmest places the universe leaves beauty behind. That even the quietest things can hold everything we need to know. And that sometimes the greatest wonder waits not in the brightest places, but in the ones we almost didn't see at all. Out beyond the glow of the familiar planets, past the gas giants and their sweeping moons, past even the pale shimmer of Pluto, the solar system becomes something else entirely. It grows quiet, the sunlight thins, the heat fades, and the worlds become fewer, smaller and softer, like fading echoes of the vibrant inner system. Here the planets no longer roar with storms or shine with rings. They simply drift, faint, cold, and patient. These are the forgotten worlds, and though they are often overlooked, they are as much a part of the solar system as any glittering giant or bustling inner planet. Over this journey you've crossed through their hidden realm. You've passed the lonely sphere of Ceres, quietly circling between Mars and Jupiter with its bright salt stains and whisper of ancient brine. You've skimmed over Haumea, the spinning ellipse flashing its icy crust like a glimmering cosmic coin. You've drifted by Makemake, glowing softly red under distant starlight, and Eris, whose discovery reshaped our definition of what a planet even is. You've watched Sedna slip through the outer dark on its immense 11,000-year orbit, and seen Orcus keep its quiet mirror dance with Neptune from the far side of the solar system. You've looked down on Quaoar and its faint ring, on the crimson marble of Gonggong, and on the faint nameless multitude, Salacia, Varuna, Ixion and hundreds more, each a spark on the dark sea. You've walked the slow gravel path of the Kuiper belt, wandered among the wild tilted orbits of the scattered disk, and stood at the threshold of the Oort cloud, where the sun becomes just another star. They are not places of spectacle. They do not blaze like Venus or swirl like Jupiter. They do not call attention to themselves at all. Most are too small for our eyes to see unaided, too far for sunlight to warm, too faint for even the largest telescopes to capture in detail. Yet that is what makes them beautiful. They're quiet in a way that feels older than time. They simply exist, unchanged for billions of years, carrying within their frozen crusts the raw materials from which all the brighter worlds were made. They are the silent foundation beneath the solar system's glittering towers. It is human nature to overlook the quiet things. Our attention is drawn to what flashes, what spins, what dazzles. We celebrate the planets that roar with storms, the moons that erupt with ice geysers, the comets that blaze with tails. The small ones at the edge rarely get their moment in the light. They are simply there, background dots in astronomical charts, footnotes in textbooks, half-whispered names. But there is something profound about finally turning toward them, about letting your gaze linger on what everyone else passes over. It feels like stepping out of a noisy room into still air, like standing in snow while the world holds its breath. Because when you do, you see what they truly are. Not scraps, not leftovers, but survivors. These tiny worlds endured the solar system's chaotic birth. They saw the giant planets migrate and settle, saw the inner planets boil and cool, saw the first comets streak and the first oceans form. They are the unaltered fragments of that ancient time, still holding the water and carbon that may have seeded Earth's oceans and skies. Every river, every tree, every cloud you know may trace its origins to these small and silent wanderers. They are not decorations at the edge of the solar system. They are part of its foundation. And in their stillness, they give something else as well, perspective. It is easy, standing on our busy, bright planet, to feel that everything spins quickly. Days rush past, years flicker, and the world never stops moving. But out there, beyond Neptune, time slows until it almost disappears. Sedna takes 11,000 years to complete a single orbit. Many objects in the Oort cloud may not have circled the sun even once since humans first walked upright. Their pace is not ours, it is the pace of mountains forming, of stars drifting. They remind us that not everything must be hurried to be meaningful. Some things endure precisely because they move slowly. There is something deeply comforting about that. The forgotten worlds are not trying to be noticed. They are not waiting for recognition. They simply circle, century after century, patient and constant. They are content to be quiet. And in a way, that is their lesson to us. That beauty is not always loud, that significance is not always bright, that sometimes the truest wonders are the ones you must go still to see. One day, perhaps, our spacecraft will glide past them. Small robotic eyes will drift over their frozen ridges, and images will beam back across the dark. Red plains of tholins, glints of buried ice, shadows of ancient craters untouched for eons. But even if we never go, they will remain, turning gently in their endless night. They do not need us to witness them to be what they are. They simply wait, as they have always waited, on the edge of sunlight. As you drift away from them now in your mind, the inner planets glimmer faintly ahead, and the forgotten worlds grow small behind you, like embers scattered on black velvet. They do not fade because they are unimportant. They fade because distance softens everything, and distance is what they know best. They are not gone. They are simply returning to their silence. And maybe that is how to leave them. Not with a bang, not with applause, but with quiet. With the same gentleness they have shown for billions of years. Let them be what they are, patient, still, and enduring. Let them turn in their faraway darkness, while you carry the memory of their quiet light inside you. The solar system is full of brilliant, roaring worlds, but it is also full of soft ones, small, cold, and almost forgotten. And sometimes it is the ones no one notices that tell the story best. So let the noise fall away for a moment. Picture the stars stretching endlessly in all directions, the sun no more than a pinprick, and the forgotten worlds circling in silence, as they have since the beginning. You're drifting past them now, weightless and unhurried, leaving them behind but not truly leaving them at all. They remain, and always will. The lights are dimming, the journey is complete, the forgotten worlds are still turning in the dark, and you are gently, peacefully on your way home.